Hello fellow problem solvers, today we're going to be doing a problem from the ELMO 2021 problem number 1. I suggest you try this geometry problem out for a minimum of 30 minutes, ideally an hour to an hour and a half, but not more than 3 hours. If on the other hand you'd like to go along with us, I suggest you draw the picture and put your first ideas out on paper for the next 15 minutes. So now, let's begin. So the first lesson with this very nice geometry problem is how you draw a diagram. So what I first did is I drew this circle, and then I drew a point A, the point of intersection D, and then I drew P and Q. And I'm not going to draw the other 2 points that we have, the points X and Y, before I figure something out about these points. So that's like solving the problem forwards in geometry and going at it step by step, seeing, okay, what does it mean that this is tangent to this? Now, I invite you to take 5 minutes and try to figure it out. Here's what I find out. So the first thing I got was this, having all these angles, x, alpha minus x, and the like. And I got nothing out of this. I couldn't see anything that I could do with gamma plus alpha minus 2x. Like, this was actually a little bit interesting, saying, is there anything I can find with this? Is there anything similar? Like I have here beta plus 3x minus alpha. Is there anything I can do with that? And because I couldn't find anything out, I was like, okay, let me actually see what the problem says. And I couldn't do anything with E. I just added it here. Now we have the other 2 points, the points X and Y. And you see you have DP intersecting this circumcircle around CQD actually. And that gives you that point. So what do I need? I just need this angle to be gamma. Let's say it's gamma, and then this gives you X. And then Y you get by intersecting this with DBP. And now an interesting thing comes to mind is that the point E is added at the end. Like, we don't use it in our problem at all. Like, the problem statement is prove that X, Y, D, E are concyclic. We did not use E at all, so there must be something interesting here happening with just these 3 points. And now before we search, we need to calculate the angles. So let's do that. Now with these angles, what do you see? Well, for me, one thing I really see is a lot of similarities. Like we have gamma, beta. We must have, what's it called? beta, gamma, alpha. Beta, gamma, alpha. Like, these two are similar. So let me write out some of the similarities and see if there's anything I can do with them. And what you get is a lot of these similarities. And now the question is, can you do with anything with them? You have also QX is parallel to PY. You have CX is parallel to AB. You have BY is parallel to AC. And there's a lot of things going on in this picture. And now with this information, I invite you to pause for 10 minutes and try to figure out what would your next step be. Like, look at all of this and figure out what would you do. So my next idea, really, when I was solving this problem, I actually got this idea. I was thinking of, I know that like I have interesting things when I intersect 2 circles, which have like the same lines. Like when I intersect these 2 circles, again, I know I have some interesting properties. And I want to prove that like this other intersection of DXY and BC is the point E. And now this is a point, call it T. What do I know? I know a lot of things actually. And I'll just show this. This is a sort of a pattern that you see in geometry, is if you have a point of intersection, have 2 lines through it, B, C, D, call this point T, then you get similar triangles. You get that TAC is similar to, so TAC is TBD are similar, and also you get that TCD and TAB are similar. So there's a lot of similarities that you can work with. And I remembered this, and I try to see what happens when I put in D. Like, what are my similarities? And the similarities I find are these 2. And I was looking at this, and I was like, okay, I have YX, QP. I can calculate these. Okay, that gives me some relationship for YX. Is it useful? Is it not? I don't know. I also have what? QY over PX. I can also have that. And I couldn't really do anything with it just now. I was thinking, is there any way I can connect it to A? Like, what do I have? I have the angle TPQ is TAQ. And then this TAQ is TDQ. Then it's here. And then that angle is also here. Right, yeah, this is here, so it's 180, so it's like TXY. So TXY and TAQ are the same. But Txy will also be Tey, that will be Ty. And now, can I do anything with that? And now I ask you to take 5-10 minutes and see if you can do anything with that. Here's the next diagram. So I tried to retrace my steps, but I just couldn't remember exactly how it came to me now. That once I added that point T, I think it was a good diagram that made me think, wait, are AT and the midpoint of BC collinear? And I tried that out, and I thought, wait, let me just define T differently. Let me just call the midpoint M, and let AM intersect APDQ be T. And now I have more things that are true about T. I have that MT times MA is equal to MD squared, which is also ME squared by the definition of E. And now I know that this angle right here plus the whole angle are 180. And I thought, wait a second, like, is it possible? So now what I would really just need to do is to prove that Y is on the circumcircle around DTE. Now let's calculate the angles first. So here are the angles, and the next idea, I invite you to pause for 5 minutes if you don't want me to give it to you. And it was that way. I need this plus this to be 180. I know this plus this is 180. So let me have the midpoint. Let me translate this on the other side. Let me take the point A prime such that A prime M is MA. And then I figure out, wait a second, BY is parallel to AC. So these 4 points are collinear. And not only that, but we also have that these 4 points, A prime E, T, D, are concyclic. And now I only need to prove that Y is on this circle. And now that is, I need to prove. So I have, what's the angle here? The angle DY A prime. This angle right here is going to be equal to what? 180 minus X minus beta. So I need what? I need the angle DEA prime. I need the angle DEA prime. And I need to show that this is X plus beta. But this angle, by pure similarity, the angle DEA prime is equal to, because this is a parallelogram, actually by parallel lines, this is equal to EDA. And what is EDA? It's X plus beta. So then this solves our problem quite quickly. And now with that, I'm going to write up a solution. So here we have, I first take M the midpoint of BC, A prime the point that makes this parallelogram, and then I have through power of point that T, A prime, D, E are concyclic. And now we have the second thing we're going to do, and that is prove that X and Y are on this circle, and we do that by, and we finish it off like this. We say, we calculate the angle, we find first that these things are parallel to each other, and then we just finally calculate the angles to prove that. First of all, Y is an element of this circumcircle around T, A prime, D, E, and then we prove by analogy that X is. This shows that these 4 points are concyclic, which finishes our problem. Now, many people just added the point A prime when they saw that this YB parallel AC and XC is parallel to AB. They just added these 2 points. I genuinely just found out, I added those 2 points once I added this point TE and took the midpoint. And that solves our problem. And as always, thanks for problem solving.